friends, my name is Jayant. Welcome to Maths with Jayant. In today's video, we are going to talk about triangles. So this is the basic introductory video of triangles, wherein we will discuss the basic steps. And what we will discuss is written in the board. So first of all, we will discuss what a triangle is. Then we will discuss about the sides, vertices and angles of a triangle. Then we will talk about something called exterior angles of a triangle. We will discuss 2-3 basic and fundamental properties of triangles and why are those properties there. We will do some activities or we will understand them, and similarly we will look at the types of triangles based on sides and based on angles. We will look at the types of triangles. So let's start with today's topic. So what's a triangle? So by definition, a triangle is a plane closed figure bounded by 3 line segments. I know it sounds complex. Let's break it and understand it word by word. First of all, a plane. What is a plane? Is it the plane wherein we'll fly and go somewhere? Of course not. In geometry, a plane means a surface. A plane means a surface. So the surface could mean a whiteboard, paper, blackboard, anything. So a plane means a surface. So a plane figure means any figure drawn on a surface. That means over here we will not consider cubes, cuboids and all. Not that. Because we cannot draw them on a surface. We can draw anything on a surface. Like let it be this. And all these are going to be plane figures. We could call so many. So all these, as they are drawn on surface, will be plane figures. Now what do you mean by plane closed figures? Closed figures. So what are closed figures? Closed figures are figures that are closed. That means, let's say I make all this. Let's say this, and all. Like look at in these 3 shapes. Are these closed? For them to be closed, they have to be the point from which they started that should reach back to the point. Over here they start here and end here. But look at over here. There is an empty gap here. There are gaps in the walls over here. And this also. So all these are categorized as open figures. Open figures. So right now we are talking about closed figures. Closed figures could look like this, and so on. So over here there are no gaps or breaks in the boundary. They start from one point and they reach back to the same point. Same thing goes here. They start at that point, they go around and reach back to the same point. So this is a closed figure. So now we've understood what a plane closed figure is. So a triangle is a plane closed figure bounded by 3 line segments. So look at this figure that I drew over here. This one is bounded by 3 line segments. It is a plane closed figure as well, and it's bounded by 3 line segments. So this is a triangle. So we can make so many different types of triangles. Let me just clear the board. So any figure that satisfies these conditions is a triangle. So I could say this is a triangle. I could say this is a triangle. And then I could say this is a triangle. 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 I can make so many triangles. All these are triangles. So now we've understood what triangles are. So now let's move on. So now let's talk about the sides, vertices and angles of a triangle. So we have drawn a triangle. So and I've named all its points A, B and C. First of all, I have a question. How will I name this triangle? So how will I name this triangle actually? Let's see. So for naming a triangle, we first put the triangle symbol. This is the triangle symbol, okay? So this triangle symbol we will put before the name of any kind of triangle. Let it be even this type of triangle. So in this name also you will put this symbol only. You will not put this symbol. Please note this. For any of triangle, you have to put this symbol only like this. Let me make it a bit more properly. Yeah, so this is how our symbol will look. And then after that, we'll put the names of all the points of the triangle. Triangle A, B, C. A, B, C. You can also name it triangle C, B, A, C, A, B, B, C, A, B, A, C. This is all up to you. So this is how we name the triangle. Now let's move on to its sides, vertices and angles. So what are its sides? So what do you mean by sides? Sides mean these lines, the line segments which have been forming the triangle. So we can say side AB. You can say line segment AB, the side of this. Similarly, line segment BC. This is another side of the triangle. Do we have another side? Yes, we do. We have side CA. Side CA. So, do we have any more sides? No, we don't. So, remember in a triangle we have 3 sides. Now, let's talk about the vertices of the triangle. So, what do you mean by vertices? So, vertices just means the corners or the points over here formed by the intersection of 2 sides. So, basically, it's the corners of the triangle, which are A, B, and C over here. I can say A, vertex A. Yeah, remember the singular of vertices is vertex. V-E-R-T-E-X. So we have vertex A, we have vertex B, we have vertex C. So these are our vertices. Do we have any more of them? No, we don't. So in a triangle, we have 3 vertices. Now let's talk about the angles of a triangle. So what are the angles of a triangle? So first of all, what's an angle? So whenever 2 lines, line segment rays meet, they form angles. That forms an angle, right? So what are the angles formed over here? One, we have this angle formed by the sides AB and AC. So this angle over here, we can name it angle BAC. BAC. Then we have another angle BAC. We have this angle as well. We have another angle. So this angle is angle ABC. Angle ABC. Can we form another angle? Do we have another angle? Yes, we do. We have this angle. So we have angle BCA. Angle BCA. Can we have more angles? Not really. So over here, did you see something? Since all these angles are formed inside the triangle, we call these angles the interior angles. So remember this. The angles formed in the inside of the triangle is called the interior angles of the triangle. And we have 3 of these interior angles. Now let's talk about a property of these interior angles. So remember something. This is a very important property. Take note of it. I'll use another color for this. So the sum of all interior angles, which I am writing as IA for now, of a triangle equals 180 degrees. Very important thing, the sum of all the interior angles of a triangle will always equal 180 degrees. So that means this angle A plus angle B plus angle C, or angle BAC plus angle UBC plus angle BCA. We can also write it by its letter. The sum of all of this will equal 180 degrees. So suppose I'm given 2 angles, I can find the third one, right? We can do this. So this is the law. Now you may be asking, Why is this law there? Why? Can you explain it? Yeah, let's do an activity for the same law. So, why is the sum of interior angles of a triangle 180 degrees? So, for this, I have taken a triangle which you can see. I have cut it. This is a very random triangle. So, it is true for all triangles. This property is true for every single triangle in the world that can be formed. If the sum is not 180 degrees, then it will not even be a triangle. Remember that. It has to be 180 degrees if this is a triangle. Now, how can we prove this? So, for proving this, I have taken a triangle. We'll do a small activity. Make sure you also do try this at home. So, for that, you cut a triangle over here and I've marked its angles. This is angle 1, angle 2 and angle 3. So, what we do is, I'll make a rough cut around all these angles. So, what I do is, over here, I put this on my board for now, like this. I pasted this angle. Similarly, we'll cut this angle as well. So, this is our angle 1, which I'll put like this, right next to this, over here, something like this. And similarly, let's cut out a final angle as well. So, we have taken out our angle 3 as well. We'll put this like this. So, you can see we have pasted all the angles. Angle 2, angle 1 and angle 3. And what did you observe? That when all these angles you keep like this, you can try this out at home. You will see that the line at the bottom of it is formed as a straight line. A straight line gets formed. Like this, we can form it. So this line is straight. And because this is a straight line, the sum of all the angles on the straight line is equal to 180 degrees. 180 degrees, right? Because this is a straight line. This is a straight line formed. So, the sum of all the angles on the straight line will be 180 degrees. Like this. That is why the sum of interior angles of any triangle will be 180 degrees. I made a very irregular triangle to show you that no matter how you cut it, this will give 180 degrees. You can try it out with any type of triangle and do this activity and tell your results in our comments box below. Does this form a straight line? Yes or no? So make sure you do try this activity at home. So now we know why the sum of interior angles of any triangle is 180 degrees. Now let's move on to our next concept. Now let's talk about exterior angles. So what are exterior angles? So for this, what we do is, let's pick up any side. Let's take the side BC. Let's take the side BC. So I extend any one of the sides. So let's say I extend BC up to D. I extend this. This is also called producing a line. So basically, when I extend BC up to a point D, this angle formed. This angle, the angle formed over here. This angle is called the exterior angle of a triangle. Like over here we have angle ACD. Now can I do this another way? Yes, I can. There are many ways where we can form exterior angles. So for now I am just writing the names of the vertices inside the triangle so that it becomes helpful. A, B, C. Let's try forming another exterior angle. Let's extend this line CA to another point. Let's say E. So this angle formed angle BAE. Angle BAE. This angle will be called the exterior angle. Can I form another exterior angle? Of course I can. Let's now pick up the side AB and extend this along till F. So this angle we get angle CBF. angle CBX. This is also an exterior angle. What are the concept of exterior angles? When a line is produced or extended, the angle formed is called the exterior angle. Now, can we form even more exterior angles? In fact, if you say no, then I can say yes, we can. We can actually. Look at this BC. We extended it till this distance. We can extend it till here as well, right? So let's extend this line to, let's say, a G. So which angle will be called the exterior angle? This angle will then be called the exterior angle. Angle ABG. Angle ABG. Similarly, we can extend BA. We've extended it here and extend it there as well. Right? Of course, we can do that. Right? So this angle formed will be the exterior angle. Angle CAH. Angle CAH. So this is how we can do it. Can we form another exterior angle? Now you will say no, but yes we can. Look at this AC. We can extend this. We have extended till here. We can extend it till here as well. Let's name this point I. So this angle formed angle BCI. Angle BCI will be the exterior angle. So in total we get 1, 2, 3, 4, 5, 6 exterior angles. 6 exterior angles, which I am writing as EXT dot angle. So we get 6 exterior angles in a triangle. So hope you get the concept of exterior angles. Now there are 1 or 2 properties related to exterior angles as well, which we will discuss right now. Now let's talk about the exterior angles properties. So first of all, we have one thing which we will note right now. So I can say that exterior angle plus the adjacent interior angle, the sum equals 180 degrees. What is this? So exterior angle, which over here I am talking about, angle ACD plus adjacent interior angle. So adjacent means next to. So the interior angle right next to it, this one, which is angle ACB. Angle ACB, their sum equals 180 degree, which you think is quite obvious. Why? Because BCD is a straight line, and as we know, the sum of our angles on a straight line is 180 degrees. So same goes for this BCD. So this plus this equals 180 degrees. So which is in fact just more of the straight line law that we've learned. Now let's note down our second property. So this one you will need to remember. So this is important. I'll make a star here. Exterior angle equals sum of interior opposite angles. Now what does this mean? So remember this one, but actually what does this mean? So exterior angle, which is this one, angle ACD, equals sum. As I heard the word sum, I know it's the addition of the quantities. The sum of interior opposite angles. So over here, as to this angle is right next to it, right? So will we consider it as an interior opposite angle? Of course not. So the leftover angles, this angle and this angle, are going to be the opposite angles. I can say angle CAB, this one plus angle ABC. Angle ABC. This angle equals this angle plus this angle. Now you may be asking for this also. Why is this thing there? What is the reason behind this? Come, let's understand this. So this is actually a sort of derived one along from two other ones. So first of all, we learned that the sum of interior angles of a triangle is 180 degree. We did the activity of cutting and doing, right? So, how can we understand this? So, first of all, I can say angle A plus angle B plus angle C. Now, over here, angle C I am referring to as this angle. Just remember that. Equals 180 degrees. We have learned this, right? Second thing, we learned that the interior angle plus exterior angle is also 180 degree. So we learned that angle C plus exterior angle C. Exterior angle C. This is interior angle C plus exterior angle C. This one is also 180 degree. Right? So this is 180 degree, this is 180 degree. So can I say that both of these are equal? Of course I can say that. So I can say that angle A plus angle B plus angle C equals angle C plus exterior angle C. So this angle plus this angle plus this angle equals this angle plus this angle. I can say that. Now over here angle C and angle C I can cancel, right? So all I'm left with is angle A plus angle B equals exterior angle C, which is exactly what we needed to prove. This is angle ACD or this is exterior angle C. This is exterior angle C equals angle CAB, which is angle A, plus angle ABC, which is angle B. Exactly what we needed to prove. So in fact, this is just a derived law from these two. So this is the property for exterior angles. So make a note of them. So now let's talk about the types of triangles before ending the session. Now let's talk about the types of triangles. So we can classify triangles based on their sides as well. We can classify them based on their sides as well as based on their angles as well. So it depends on their sides as well we can classify, their angles as well we can classify. So let's just look at each one categorization one by one. Let's talk about the types of triangles now according to our sides. So according to sides, what type of triangles can we make? One type where all sides are equal. So these lines show equal. Another type wherein two sides are equal and a third side is different. So these lines represent the length of the sides. So over here, since both of them are represented by one line, that means that these two are the same length. And this type where no sides are equal. So over here, this type of triangle, let's look at the first type. All sides are equal, and when all sides are equal, all angles are also equal. So all sides are equal and all angles are equal. Okay, now let me ask you a question. What will be the measure of each angle? Now all angles are equal in this triangle. Can you find that angle? You might say no, but actually yes you can. How? Because we know that the sum of interior angles of a triangle equals 180 degree. This is what I am telling you. This was so useful, it will be so in almost every single question of triangles. So over here, we know that each angle is equal, right? So let's say each angle is some x degree, x degree, x degree and x degree. So I can add x plus x plus x, x plus x plus x equals 180 degree. The reason because the sum of interior angles of a triangle is 180 degree. Now 3 x's are being multiplied together, so I can add it together. So 3x equals 180 degree. That's why x equals 180 degree divided by 3, which equals 60 degrees. So rather than write, so all the measure of each angle will be 60 degree. So all angles are 60 degree in measure. So this is going to be all sides are equal, all angles are equal. But the main question, what do you call such type of triangles? Such triangles are called equilateral triangles. equilateral, equilateral triangles. This is the name. All sides are equal, all angles are 60 degrees. Now now let's talk about our next type of triangles. Over here we have two sides are equal. And now what about the angles? So look at these two are the equal sides. So are there any angles equal here? Yes sir. So the angles opposite to the equal sides. That means this angle and this angle. This angle we are not talking about. We are talking about these two angles. These two angles are equal. So in this type of triangle we can say that. So what do you call such triangles? Such triangles where two sides are equal and two angles are equal, we call these type of triangles isosceles. The spelling is different, please remember that. isosceles, isosceles triangles. So over here, two sides are equal and two angles are equal. Now let's move on to our last type, where no sides are equal, no angles are equal. So in such triangles where no sides are equal, no angles are equal, everything is different. Such triangles, we call such triangles as scalene triangles. S-C-A-L-E-N-E, scalene triangles. So the three types of triangles are equilateral, all sides are equal, all angles are equal. Isosceles triangles, two sides are equal, two angles are equal. Scalene triangles, no sides are equal, no angles are equal. So this is how we can categorize based on sides. Now let's learn how the types of triangles according to angles. And now finally let's talk about the types of triangles based on the angles. So first let's look at this type of triangle. Over here all angles are acute. But what do you mean by acute? Acute angles are angles that are less than 90 degrees. So acute angles are lesser than 90 degrees but greater than 0 degrees. So over here, tell me, all these angles are they 90 degrees or less than 90 degrees? Clearly they are less than 90 degrees. Because for 90 degrees, the line, if it were 90 degrees, the line should have been like this. So this is clearly an angle should have been from here to here. And this is not how it is. Over here, since all angles are acute, we call them acute angled triangles. Acute angled triangles. Easy, since all angles are acute, call them acute angled triangles. Now let's talk about right angled triangles. Okay, I told the name already, but what are right angled triangles? Right angled triangles are triangles where one angle is right. What do I mean by right angle? Right angle means 90 degrees. So these are called right angle triangles. But remember, in right angle triangles, one angle is 90 degree, not all angles. Only one angle is right angle. And right angle means 90 degree. Now right angle triangles are very important because we have Pythagoras theorem only based on right angle triangles. Right angle triangles, just remember, they are very important things. Right angle triangles. So let's just look at its basic terminology. So this side which does not help in forming the right angle, which is not helping in forming the right angle. These two sides forming the right angle. Or so the side opposite to that, like this one. It is called the hypotenuse. Hypotenuse. This is the longest side of a right angle triangle. Now let's look at this type of triangle. Over here, what do you see? The marked angle, one angle over here is obtuse. What do I mean by obtuse? Obtuse angles means greater than 90 degree. So if at all the angle were 90 degree, then the triangle should have looked something like this, less than 90 degree. But clearly it is more tilted. It's more tilted. So here one angle is more than 90 degrees. One angle is obtuse. And what do obtuse angle mean? Obtuse angles are angles that are greater than 90 degrees but lesser than 180 degrees. So what this is that 90 degree lesser than obtuse, lesser than 180 degree. What I mean by this is that obtuse is more than 90 degrees, lesser than 180 degrees. So one angle is obtuse, then such a triangle is called an obtuse angled triangle. Obtuse angled triangle. So these are the three types of triangles. One acute angle triangle or the right angle triangle, third obtuse angle triangle. Remember, in acute angle triangle, all angles must be acute. In right angle triangle, one angle should be right. In obtuse angle also, one angle should be obtuse. Now you may be asking why one angle should be 90 degrees in the right angle triangle. So we know that a triangle has three angles. There cannot be two right angles in a triangle. Why? Because let's say that we have three angles. We have 90 degree plus 90 degree and 90 degree and some other angle. Let's even call it 10 degree. If these are the angles of a triangle, we need to check if a triangle gets formed. So if this will form a triangle, the sum of all the angles will be 180 degree. But over here, are we getting 180 degree? Of course not. 90 plus 90 is 180, 180 plus 10 is 190. So we are not getting 180. That's why a triangle is not only formed when there are two right angles. Same goes with obtuse, because obtuse are even bigger than 90 degrees. Do you think they will form a triangle? No, of course not. So that's why remember that there will only be one right angle and one obtuse angle in a triangle. So hope you liked my video, and if you like this video, then please give this video a like, share it with your friends, and don't forget to subscribe to my channel. And here you can see the triangles playlist, wherein I'll be adding more videos on triangles, and then you can watch them as well. So hope you like my video. Thank you very much.